Today's video is section 3.5, Limits at Infinity. The homework for this section is 15, 17, 19, and 21 through 30. So, this is different than yesterday. Yesterday was infinite limits. In infinite limits, we were approaching vertical asymptotes in which the limit did not exist, but we were stating from the right or the left it was approaching positive or negative infinity. Well, now this is limits at infinity. So kind of an informal definition or letting you know what these are. These are limits that are one-sided and either are approaching positive or negative infinity. So you're not approaching 2 or negative 2 from the right or left. You're going to be approaching positive or negative infinity. For the limit to exist, it must be approaching a horizontal asymptote. So let's see what that looks like. So let's take this first problem. The limit of 3x squared all over x squared plus 1 as x approaches positive infinity. So that's what these limits are at infinity. So I'm looking at a one-sided limit as x approaches positive infinity. What is my y going to be approaching? Remember, that's what the limit is. What is my y approaching as my x gets closer and closer to positive infinity? So what I did is I went ahead and I sketched out this graph. I don't expect you to know what it looks like. And you can tell that there is a horizontal asymptote at 3. So as I keep getting closer and closer to positive infinity, this limit is getting closer and closer to 3. It does exist. Even though it's one-sided, it's approaching my horizontal asymptote. There's no way I can approach it from the other side. So here's another example. The limit of 2x minus 1 over x plus 1 as x approaches also positive infinity. So by sketching out the graph, and as my x's that I'm choosing are getting closer and closer to positive infinity, my y's are getting closer and closer to that asymptote of 2. That's what the y is getting closer to. On this third example, the limit of 1 over x squared plus 1 as x approaches, again, positive infinity. Here's a sketch of that graph, and so hopefully you can tell by the sketch that there is a horizontal asymptote at y equals 0. So as my x's get closer and closer to positive infinity, my y's are getting closer and closer to 0. So if you recall, last year in pre-calculus, we dealt with horizontal asymptotes. So I'm going to put up what you were supposed to have learned last year. Remember in pre-cal in chapter 2 about horizontal asymptote. If n is less than m, and so what is this dealing with? This is dealing with the numerator's leading exponent and the denominator's leading exponent. So if n is less than m, then there is a horizontal asymptote, and it's y equals 0. If n equals m, or the two leading exponents in the numerator and denominator are identical, then the horizontal asymptote is y equals a sub n over a sub n. In other words, the leading coefficient in the numerator and the leading coefficient in the denominator. Then if n is greater than m, then there is no horizontal asymptote, and there's a possible slant asymptote. And with a slant asymptote, so however I'm going to be approaching, it's going to go to positive or negative infinity. These limits are not going to exist because they're not approaching a horizontal asymptote because there is no horizontal asymptote. So let's use this and let's look at the 3 problems I just did. So for this one here, my n is 2 and my m is 2. That would be this example. We said the horizontal asymptote is the leading coefficients. that would be 3 over 1, in other words, 3, which is true. This one here, my n is 1 and my m is 1, so it is still this one. Therefore, my horizontal asymptote is 2. This one here, I could put in the numerator x to the 0 power. This would be 0, this would be 2. That would be this case. N is less than m. Then the horizontal asymptote is 0, which is true by the sketch of the graphs. So if I'm going to positive or negative infinity, I'm approaching that horizontal asymptote. So let's look at some algebraic techniques to find limits at infinity. Because what if you don't have the graph? And you don't get to use the shortcuts from pre-calculus. So the first one, number 16, I'm going to do some of the evens that were not assigned to you. F of x equals 5x squared minus 3x plus 7. So the first thing I want to do is I want to find the limit of this over this. So what I'm doing in the different parts, which I'm modeling what some of your homework is going to look like, number 15 and 17. That's going to give you a function, and then in the different parts, A, B, and C, they're putting a different denominator down here. So in this first part A, it was x to the first power. So now if I put infinity into here, that's infinity, then 5 times infinity squared, that's just infinity, minus 3 times infinity, that's infinity, plus 7. In other words, infinity over infinity. That is called also an indeterminate. Well, I can't find that limit. So here is the algebra technique that I have to use. So let's take a look and see what I did. So what you do is you take a look at the denominator and you look for the leading exponent. Well, it's 1. So now you're going to divide every single thing by that denominator. So this is going to be 5x squared over x minus 3x over x plus 7 over x. I'm going to divide everything by x. In other words, I'm just breaking up this one fraction into 3, giving each one its own x. Let's simplify that. That's x squared over x, that's just 5x, minus, that's just 3, plus, oh, he's got to stay. So now let's take the limit of each piece. The limit of 5x, put infinity in, substitute, minus the limit of 3, it's just 3, plus take the limit as x approaches infinity for 7 over x, well, I just drop in infinity. So 7 over a huge number, it's really just approaching 0. So infinity minus 3 plus 0, it's just infinity. But that makes sense that this limit is not existing. Let's see if I can find those notes again. Here, my n is greater than my m. There is no horizontal asymptote. There's a possible slant asymptote, but either way, if there's no horizontal asymptote, that limit is not going to exist. Let's try part B. Part B has the function in the numerator divided out by x squared. Again, I'm going to double check that it's an indeterminate. Infinity squared is infinity. Put infinity for everything, that's still infinity. I must go ahead and redo this. So how I'm going to do that is I'm going to put x squared, I'm going to divide this up one fraction into 3. I can do that, give each one its own denominator. So in doing that, it's just 5 minus 3 over x plus 7 over x squared. Now I'm going to go ahead and take the limit and actually drop in infinity. The limit of 5 minus 3 over x plus 7x squared is 5 minus 3 over infinity plus 7 over infinity squared. 3 over a huge number, that's just going to 0. This is just going to 0. So the limit is just 5. I'm going to go ahead and check my work with what I remember in pre-calculus. Let's see. My n and m are the same. My n and m are the same. My horizontal asymptote is y equals the leading coefficients. Y equals, let's see, the leading coefficient is 5, is 1, 5 over 1, 5. You must show me this work. You may not use pre-calculus just to jump to it, but it's a wonderful check. Part C was for me to take the same numerator and put it over x cubed, and let's see what happens there. So again, I'm going to give each one its own denominator, which I can do that. And then I'm going to go ahead and simplify 5 over x minus 3 over x squared plus 7 over x cubed. I'm going to drop in infinity. I'm going to go ahead and take the limit, put infinity in here, and here, and here. They all go to 0, so the limit is 0. Now I'm going to check my work from pre-calculus. The original function, the n is smaller than the m. The n is smaller than the m, then the horizontal asymptote is y equals 0. And this limit will only exist as I'm approaching positive or negative infinity if it has a horizontal asymptote, and that's what it's approaching, 0. So divide each term in the numerator and denominator by the variable with the highest exponent in the denominator. Let me show you a few more examples of that. So the limit of 3x minus 2 over x approaches infinity, the limit of 3x minus 2 over the square root of 2x squared plus 1 as x approaches infinity. Let's put infinity in here. And 3 times infinity minus 2, that's still infinity. And then infinity squared times 2 plus 1, take the square root of it, it's just infinity. That's an indeterminate. I can't find that. So the technique was to divide each term in the numerator and denominator by the variable with the highest exponent in the denominator. So I'm going to go to the denominator. It says x squared, but if that stood alone and I saw the square root of it, I know it would be just x to the first power. So I'm really going to divide everything in the numerator and denominator by x to the first power. So let's do that. So 3x over x minus 2 over x. Then take the entire denominator and divide it by x, except this is underneath the square root. I would like this to be underneath the square root so I can have one giant square root so I can simplify all this. So instead of writing x, I could just write the square root of x squared. That's the same thing as x. Now watch what happens. I'm going to clean that up. That's just still minus 2 over x. And so this one here, in fact, I went a little fast. Let me show you what happened. I get to have one large square root, put 2x squared plus 1 over x squared. I'm allowed to do that because each one has its own square root. So I can put it all underneath 1. When I clean that up, I'm going to go ahead and give each one its own denominator. So this is just 2 plus 1 over x squared. Now let's go ahead and take that limit. 3 minus 2 over infinity. 2 over infinity is 0. 2 plus, put in infinity, 1 over infinity is 0, so it's really just square root of 2. And yes, I could continue and rationalize the denominator, and then I would get 3 square root of 2 over 2. Let's try that one more time. And I know you're going to have to do quite a bit of the problems in class tomorrow to really understand all this. That's okay. That's why we're doing it this way. The limit of 3x minus 2 over the square root of 2x squared plus 1 as x approaches negative infinity. Oh, it's actually the exact same problem. So I drop in the negative infinity. And actually, I would get something like this, because the negative infinity would go in here. Negative infinity times 3, that would just be negative infinity. Negative infinity squared times 2 plus 1, just a positive infinity. But either way, that's an indeterminate. So let's go ahead and use our technique, was go into the denominator. That's really, I know you see an x squared, but if I take the square, that's really an x. So that means I need to divide every one of these terms by x. By x, by x, but because this has a square root, I would love to have one giant square root and simplify underneath. So let's divide by a square root of x squared, which is really still x. To compensate for the negative that I'm approaching, the negative infinity, you're going to put a negative here. It will compensate for the negative. So let's just continue. The limit as x approaches negative infinity, that would be 3 minus 2 over x. My negative is still sitting there. I clean that up just like I did last time. So put in negative infinity, right? Negative infinity. That'd really be 3 plus 0, which is just 3. Put in negative infinity, square it. That's just a 0. Square root of 2, and my negative on the outside. So my answer is negative 3 square root of 2. Thank you.